This video is about solving radical equations. To solve radical equations, it's crucial that we know the squaring property of equality. This property states that if both sides of an equation are squared, then all of the solutions of the original equation are among the solutions of the squared equation. In other words, if a equal b is our original equation, and a squared equals b squared is our squared equation, then the solution set of a equal b must be a subset of the solution set of a squared equals b squared. We're going to invoke this property to solve radical equations. I'm going to go over the following 6 examples step by step. Let's start with the first example. Square root of x plus 1 equals 3. To solve this equation, I'm going to square both sides to get rid of the radical on the left side. So square root of x plus 1 squared equals 3 squared. X plus 1 equals 9, which means x equals 8. This is the solution of the squared equation. It may or may not be a solution to our original equation. Let's check. Let's check whether x equals 8 is a solution to square root of x plus 1 equals 3. If we plug in x equals 8 on the left-hand side of our original equation, we get that the left-hand side is square root of 8 plus 1. That's square root of 9. That's equal to 3. And that's equal to the right-hand side. So x equals 8 is indeed the solution of square root of x plus 1 equals 3. Next example, let's solve 3 square root of x equals square root of x plus 8. We start by squaring both sides. 3 square root of x squared equals square root of x plus 8 squared. 9x equals x plus 8. 8x equals 8, which means x equals 1. That is the solution of the squared equation. Let's check whether that's also a solution of the original equation. If we plug in x equals 1 on the left-hand side of our original equation, we get 3 square root of 1, which is 3. If we plug in x equals 1 on the right-hand side of our original equation, we get square root 1 plus 8. That's square root of 9, which equals 3. Since the left-hand side equals the right-hand side, x equals 1 is a solution to our original equation. Example 3, let's solve x equals square root of x squared plus 5x plus 10. We start by squaring both sides. So x squared equals square root of x squared plus 5x plus 10 squared. That's x squared equals x squared plus 5x plus 10. That's 0 equals 5x plus 10. That's 5x equals minus 10, which means that x equals negative 2. That's the solution of the squared equation. Let's check whether that's also a solution of our original equation. Let's plug in x equals minus 2 in the right-hand side of the equation. When we do that, we get minus 2 squared plus 5 times minus 2 plus 10. That's equal to 4 minus 10 plus 10. That's the square root of 4, which equals 2. When we plug in x equals minus 2 in the left-hand side of the original equation, we get x, which is minus 2. As you can see, the left-hand side and the right-hand side are not the same. So although x equals minus 2 is a solution of the squared equation, it is not a solution of the original equation. So x equals x squared plus 5x plus 10, that's our original equation, has no solution. Example 4, let's solve the equation square root of 2x minus 3 equals x minus 3. We start out by squaring both sides to get rid of the radical on the left-hand side of the equation. So, square root of 2x minus 3 squared equals x minus 3 squared. 2x minus 3 equals x squared minus 6x plus 9. Moving everything to the right-hand side, we have 0 equals x squared minus 8x plus 12. We can solve this last quadratic equation by factoring the right-hand side, and to do that we need two numbers that multiply to 12 add up to negative 8, while negative 2 and negative 6 do the trick. So the right-hand side factors as x minus 2, x minus 6, which means x equals 2 or x equals 6. These are the solutions of the squared equation. Let's check whether these are also solutions of the original equation. Starting with x equals 2. If we plug in x equals 2 in the right-hand side of the original equation, we get the right-hand side equals 2 minus 3, which is negative 1. If we plug in x equals 2 in the left-hand side of our original equation, we get square root of 2 times 2 minus 3. That's square root of 4 minus 3, which is 1. Obviously, the left-hand side and the right-hand side are not equal to one another. So, x equals 2 is not a solution to our original equation, square root of 2x minus 3 equals x minus 3. So x equals 2 is ruled out. Now let's check whether x equals 6 is a solution to our original equation. If we plug in x equals 6 on the right-hand side, we see that x minus 3 is 6 minus 3, which is 3. If we plug in x equals 6 in the left-hand side of our original equation, we get square root of 2 times 6 minus 3. That's square root of 9, which is equal to 3, and that's equal to the right-hand side. So, x equals 6 is a solution to our original equation, square root of 2x minus 3 equals x minus 3. And we find that x equals 6 is the only solution. Example 5, solve square root of 21 plus x equals 3 plus square root of x. Let's square both sides to get square root 21 plus x squared equals 3 plus square root of x squared. 21 plus x on the left side equals 9 plus 6 square root of x plus square root of x squared, which is x. Notice that x and x cancel each other out, and we're left with 21 minus 9, which is 12, equals 6 square root of x. Divide both sides by 2 to get 2 equals square root of x, and square both sides to get 4 equals x. That's the solution of the squared equation. Let's check whether it's also a solution of the original equation. Plugging in the left-hand side gives us 21 plus 4 under the square root. That's square root of 25, which is equal to 5. Plugging in the right-hand side, we have 3 plus square root of 4. That's 3 plus 2, which equals 5, which in turn equals the left-hand side. So x equals 4 is our solution for square root 21 plus x equals 3 plus square root of x. Finally, let's solve cube root of 5x equals cube root of 3x plus 1. Here, squaring both sides will not get rid of the radicals. What we need to do is cube both sides, because when we cube a cube root, the radicals go away. So we start by writing cube root of 5x cubed equals cube root of 3x plus 1 cubed. This gives 5x equals 3x plus 1, 2x equals 1, so x is 1/2. That's the solution of the cubed equation. Let's check whether it's also a solution of our original equation. Let's plug in the left-hand side. That gives us cube root of 5 times 1/2, so that's 5 over 2. If we plug in x equals 1/2 for x in the right-hand side, we get cube root of 3 times 1/2, that's 3 halves, plus 1. That's cube root of 3 over 2 plus 2 over 2. That's cube root of 5 over 2, which equals the left-hand side. So x equals 1/2 is a solution of our original equation.